Okay, so this was the question that you guys were given in class, and I just wanted to do a quick video on those people that wanted to know how to do it. So, um, if you were looking for the surface area just inside this cubby here, the one that's outlined in red, um, let's just get my pen going here. Okay, so yeah, so this guy here. There would be three rectangles. There would be, so I'm going to do the surface area of the cubby. So that's the whole inside of the thing. Okay. Cubby is very badly written because it's really hard to write on these whiteboards. Anyways. All right. So there we have our cubby. And we would have the back rectangle. Okay, so that thing right in the back there. So that's going to be dimensions 90. And now, what is the height of this? So if we look at this, we want just that height. The height of the whole thing we know is 120. Okay, but the height of each shelf, of which there are, split into four pieces. Okay. And it says that they are equal distance, okay, between the top shelves. So that would mean that if we wanted to find this height here, we would just take it and divide by 4. So 120 divided by 4 is equal to 30. So this height here, okay, would be 30. All right, so now I can do this as 30, and there's only one of those. Plus, there's going to be 2 of the rectangles that are, I'm going to draw it like this so that you can see which one I'm talking about, the one that's flat. Okay, so that's going to be a distance of 90 a length of 90 and a width of 24. And there is one on the bottom here, but there's also one at the top. So the only thing I can do really is draw an arrow. So basically the ceiling of the cubby. So I'm going to multiply that by 2 plus 2 times then the sides of it, which are going to be 24 by 30. So 24 by, where am I going to write this 30? I'm running out of space. I'll scooch over a little bit. 30. Okay. So, and there's going to be 2 of those. So I can go ahead and multiply that. So this one's going to be 2,700. This is going to be 2,160. And this one here is 720. Okay. So then my formula is just that. Plus 2 times this plus 2 times the 720, which ends up giving me 8,460. Okay, so that's for the cubby. So that's essentially part A. Part B asks you to find, let's look at part B and C. It asks you to find the total surface area. And then in C, I'm going to just answer them both at the same time. It says, what is the fewest number of surfaces for which you need to find the surface area in order to answer part B? So I'm just going to answer B based on finding the fewest number. Okay. So if we look at our shelf, we can look at it as 3 parts. There are these, okay, which we would have, there's 1, 2, 3, 4, 5 of them, but there's a top and a bottom to each of them. So if there's 5 and there's 2 sides, that would be a total of 10. So one of the rectangles, okay, is this shape here, which is the 90 by 24, which ended up being 2160, right? And there are 10 of those, okay? Plus, so this is the surface area of the whole bookcase, or I could call it a composite object, okay? So there's going to be 10 of those. Then on the side here is another rectangle, that guy, okay? So this rectangle on the side, there is one on this side and there's one on this side. Okay, so I'm going to draw that. Okay, and it's 120 by 24. Now, because there's going to be, once again, 2 sides to that, there's going to be the side and the outside and the inside of both of those. So that's a total of 4 of that size rectangle, which ends up being 2880. Okay, when I multiply that together. And then the last rectangle that there is the back one. Okay, so that's going to be this one in the back. So the back of the bookshelf. And that's going to be a 90 by 120, and which will give us this. Okay, but how many of those are there? Well, there's the one that's inside the bookcase, and then there's one that's on the outside of the bookcase. So there's going to be 2 of those. All right, so it would be 10 times that plus 4 times this vertical dude plus 2 times this. Okay, for a total of 54,720. Okay, I hope that helps. Bye for now. Or